Hello everyone, welcome back to our channel. We are back again with a new video. In this video we are going to create a Brownian motion pattern using Python. So let's start this by importing the required libraries. So here NumPy is used for efficient numerical operations including random number generation and array manipulations, and matplotlib is used for plotting and visualizing Brownian motion paths. So now we'll define the parameters. So here n is the number of particles and t is the number of time steps. So as n is the number of particles that will undergo Brownian motion and t is the number of time steps, meaning each particle moves 500 times, and step size is 1, which is the fixed distance a particle moves at each time step. And now we'll initialize position arrays. So here x and y arrays, these are n into t matrix, which is 10 into 500 in this case, which is initialized to zeros, and each row represent a different particle and each column represent a time step. Initially all particles start at 0, 0. And now we'll simulate Brownian motion. So this loop over time steps excluding the first step. So this generates n random angles from 0 to 2 pi. So here this line measures and update x coordinate and this line measures and update y coordinates. So now let us understand. Here for I in range, this loops through t minus 1 times steps from 1 to 499 because the initial position t is equals to 0 is at 0 by 0 and angle is equals to 2 into np.pi. This generates n random angles between 0 and 2 pi, which is a full circle for random movement in any direction. And here for x direction, the next x coordinate is determined by adding cos angle, which is step movement in x direction, and y direction is the next y coordinate is determined by adding sine angle, which is step movement in y direction. Since angles are random at each step, particles move in completely unpredictable direction. And now we'll plot the Brownian motion paths. So this sets the figure size to 8 inches by 6 inches. So here this loop ranges through each particle where n is equals to 0, and plt.plot this plot each particle's path using lines where Lw is equals to line width, which is set to 1.5 for better visibility, and alpha is equals to 0.7, which makes line slightly transparent for better visualization. So this marks the last position of each particle with red circles. Starting position is 0 by 0, where plt.scatter this marks the starting point with the black X. And now we'll customize the plot. So here plt.title adds a suitable title to the plot, and plt.x and y label this x-axis label the x-axis, and y label labels the y-axis. And now we'll add legend. So plt.legend displays the labels for the final position and the starting point, and plt.grid adds a grid for better visualization, and plt.show displays the final plot. And now we'll check this. So we can see a Brownian motion pattern. So thanks for watching this video.